Is our reality 3D or 4D? Or how many dimensions actually are there? Is it the only world existing? Are there others? How many? Can we see them? Can we travel there? What is the difference between space, world, and reality? So many questions. I'll share with you my answers, which can be fuel for your own ones. This video is carefully designed to gradually introduce concepts that can only be comprehended on an abstract level. It starts with simple examples and steadily increases in complexity, leading up to the most fascinating conclusions. However, if you find long explanations boring, feel free to skip directly to the essence by using the time codes in the description box below. Let's start from the very beginning here. We are living in a three-dimensional space. Some might say no, it's four-dimensional because time is there. Actually, time is a dimension for the space-time continuum, which is then four-dimensional for us. Or, as Einstein called that, a manifold, where space and time are all equal dimensions. So then, yes, time is a dimension of that manifold or space-time continuum, or we can say with some extension of this world. But the space itself that we are living in is three-dimensional. Therefore, here and further, space will be used as a term for its actual meaning, field or extent or area, in the case of our world, a three-axial space. Okay, so then, is that the only possible space that can be? Mathematically, no. Let's dive into that. Starting with zero-dimensional space, which is a point, not even a dot, as a dot has size, no matter how small, but point because it has no size or zero size using our spatial measurement. But our spatial measurement is not applicable to point. It is hard to imagine, but there are no measuring axes at that point. There is no size as we understand it. It has no width or height. It's just this point which actually has no size, because whatever size we can imagine will be the attribute of a higher dimension, for example, of our three-dimensional space. So how many points can be imagined, or better to say postulated, meaning how many points exist? Within a higher dimensional space like ours, an endless amount. And outside of any space, well, nothing stops us from assuming that it can be an endless number as well. This is totally out of imagination, yet still no principle, mathematical or physical, is violated. Let's fix it as idea number 1. An endless number of zero-dimensional spaces exists. One-dimensional space is a line that has no beginning, no end, so it is endless. Let's start with a straight line for ease, but it can be curving, intersecting itself, or closed on itself, or take on any other possible variation. However, let's consider a simple option, a straight line. This line is one-dimensional space. It has one axis, meaning it has one spatial measurement, length, or distance between points. And points of this line are entities of this line, of this one-dimensional space, or we can call them even events of that space. And how many points does line contain? An endless amount. And each point is zero-dimensional space. Let's fix that as idea number 2, meaning each one-dimensional space contains an infinite number of zero-dimensional spaces in it. And how many lines can exist? An endless amount, at least within higher dimensional space, which means an endless amount of one-dimensional spaces exist, the same as for zero-dimensional spaces. So we can extend idea number 1. An endless number of zero and one-dimensional spaces exist. Okay, an endless amount of lines. Some of them are crossing, some not. Still, for those crossing lines or intersecting 1D spaces, the intersection is a point, which means intersection is a zero-dimensional space. We will remember that as idea number 3, as it will repeat extensively further. One-dimensional spaces intersect at zero-dimensional space. And how many lines going through a certain point can be postulated? You already got the idea. An infinite number. And that will be idea number 4. An infinite number of different one-dimensional spaces contain a certain zero-dimensional space, or vice versa. Each zero-dimensional space exists in an infinite number of different one-dimensional spaces. By the way, if the line curves and crosses itself, it means that this is a point in that line, that one-dimensional space, which belongs to different parts of that space, kind of a crossroad. And the line closed on itself creates cycles of the same points. That is food for thought, or idea number 5. Let's move on to two-dimensional space, which is a plane. It has two axes, two measurements of space, two coordinates if we postulate a system. Again, it can be flat, to the same degree as parallel lines, or curved, as an example, a torus or any other form, including self-intersecting. And all the ideas we talked about before are applicable here as well. How many planes do exist? That is idea number 1. An infinite number of planes or two-dimensional spaces exists. How many lines do exist on the plane? That is idea number 2. An infinite number of one-dimensional spaces exist in two-dimensional space, or two-dimensional space contains an infinite number of one-dimensional spaces. How do planes intersect? Exactly, that is idea number 3. Planes intersect at a line. In other words, two-dimensional spaces cross at one-dimensional space. How many planes can be postulated containing a certain line? That is idea number 4. An infinite number of different two-dimensional spaces go through a certain one-dimensional space, or each one-dimensional space exists in an infinite number of different two-dimensional spaces. And idea number 5, two-dimensional space can be self-intersecting and therefore have crossroads, or be closed on itself and therefore have cycles of events. So now we can move to our three-dimensional space with 3 axes and extend all the same ideas using induction method. Idea number 1. An infinite number of three-dimensional spaces exists even though we realize just one, ours. Idea number 2. An infinite number of two-dimensional spaces exists in three-dimensional space, or three-dimensional space contains an infinite number of planes. Idea number 3. Three-dimensional spaces cross at two-dimensional space. Idea number 4. An infinite number of different three-dimensional spaces go through a certain two-dimensional space, or each plane exists in an infinite number of different three-dimensional spaces. Idea number 5. Three-dimensional space can be self-intersecting, which by the way means that if our world, our 3D space is like that, intersecting itself, then there are points having the option of multiple outcomes. And what if the form of that space is that complex that each point has multiple outcomes? Then we come to the concept of choice and free will and life crossroads, and not just a philosophical concept but a mathematical one. Also, 3D space can be closed on itself, which means that if our world is like that, then cycles of events appear, therefore cycles of time, and Vedic concept of repeating yugas or wheel of yugas, those cycles of time, has a mathematical explanation. By the way, theoretically, parallel lines and parallel planes exist, those that do not intersect. In that case, we can always postulate a line or a plane that crosses them and connects them this way. According to Einstein's theory of general relativity, our space is curved by massive objects, and parallel lines approach each other near the massive objects, and the idea of parallelism is harder to imagine. For example, black holes are curving space and also time so much that scientists assume space and time collapse in the center of a black hole at a singularity point. They stop existing. But we cannot experimentally test it. We don't have even equations for that, as quantum mechanics ends somewhere before that event, due to Planck constant limitations. Okay, somewhat clear about lines, planes, and 3D spaces. Is that the end? Or does four-dimensional space exist? Or even a higher dimensional one? Well, string theory, for example, operates with 11 spatial dimensions, most of them curled up and invisible to us. But string theory is not proven, so it is a hypothesis, frankly speaking, not a theory. But mathematics, anyway, does not limit reality. The Hilbert area, where all the quantum mechanics exist, has infinite dimensions. Exactly, infinite. Not just 4, 5, 1,000 or billion, but an infinite number of dimensions, endless. Some might say it is only an abstract mathematical theory. So far, mathematics has not discredited itself ever. It is a perfect abstract instrument to describe the material world around. And as long as our knowledge about the material world is limited, we tend to say abstract things do not exist. There was a moment when natural numbers up to 1,000 were enough to describe the world around, to count birds and trees, and infinity was not even needed. And yet, here we are using math to explore the world further. Also, for example, black holes were first found mathematically. Schwarzschild's solution came from Einstein's field equations in 1916. Observational confirmation came decades later. At that time, Einstein said this whole black hole idea was nonsense, and yet again, here we are having formulas describing time dilation approaching the black hole. Still just guessing what is happening in the very center of a black hole. Getting back to infinite possible dimensions existing. So if space can have limitless number of dimensions, then we can inductively extend the previous ideas and summarize that an infinite number of spaces of any dimension up to infinitely dimensional spaces exists. Each n-dimensional space contains an infinite number of n-1 dimensional spaces, and it is applied recursively. N-dimensional spaces intersect at n-1 dimensional space. An infinite number of different n-dimensional spaces go through a certain n-1 dimensional space. N-dimensional space can intersect itself or close on itself. In other words, there are other three-dimensional spaces than ours, an endless number of them, and our three-dimensional space intersects with at least some of them. And our three-dimensional space is an intersection of an endless number of different four-dimensional spaces. Wow, that takes time to absorb. It is hardened by our inability to imagine four-dimensional space, as we are three-dimensional creatures, and our mind is limited by its dimensions. We can use projections or intersections, but that's it. Like a three-dimensional ball intersects at a disk with a two-dimensional flat plane, or at a segment with one-dimensional line, or at a point with zero-dimensional space, a point itself. The same, any four-dimensional object will intersect at a three-dimensional object with our space, but it doesn't mean it is the whole object itself, just an intersection, a part of it. Then, logically, we can assume a three-dimensional ball from the previous example is an intersection of a four-dimensional, let's say, ball with a three-dimensional space, and that four-dimensional ball is itself an intersection of five-dimensional ball with four-dimensional space, and so on up to infinity. We don't know what those balls in upper dimensional spaces look like. We also don't know what physical laws are applicable there, and what energies are part of those higher dimensions. It just gives us a clue about the infinite spatial nesting of things. This way, the whole reality can be defined as infinitely nested, infinitely dimensional space, where not only spaces of different dimensions are nested one into another, but also at every point or event or moment of every space. Mind-blowing and impossible to imagine. Our imagination cannot absorb in full extent the idea of one simple infinity even. What can we say about infinitely nested infinities? And I will call it idea number 6. Also, we come to idea number 7. All our 3D objects, including us, are parts of higher dimensional objects, infinitely nested. We could be just part of something bigger and more sophisticated in higher dimensions, like MRI slicing and dicing of the 3D brain and getting to the images, which are not the whole brain. And here it comes to idea number 8. Objects or creatures of n-dimensional space can only observe or realize objects or creatures of equal or lower dimensional spaces, and cannot realize objects or creatures of higher dimensional spaces at full extent. Only their intersections with the observer's space. Let's imagine a line on the flat plane in the three-dimensional space. And let's imagine an object on that line, a segment. It can only so-called know what is happening on the left and on the right of it, but not around the line. It doesn't know anything about around itself, about any object on the plane this line belongs to, and nothing about the 3D space this line and plane are in. As well, the plane object can only observe other objects of this plane, but not anything else of the three-dimensional space it is in, even other two-dimensional objects if they do not belong to its own plane. And correspondingly, we as creatures of our three-dimensional space of our world cannot see, observe, know, or detect any objects of higher dimensional spaces we are in, as well as three-dimensional objects or other three-dimensional spaces that exist along with ours. But can we go there to other three-dimensional spaces? Theoretically, all spaces are connected, either crossing with one another or through a third one crossing both, like lines crossing or parallel, or planes crossing or parallel, or three-dimensional spaces crossing or parallel. And as we postulated in idea number 3, n-dimensional spaces cross at n-1 dimensional space. Let's first consider it with an example of planes. Two planes intersect at a line. If they are parallel, we can always define another plane that intersects the previous both at lines. So to get from plane 1 to plane 2, the object should go through the line, the space of a lower dimension. Should it collapse to a -1 dimension and then unfold again? I will answer soon. Respectively, if a three-dimensional object transfers from one three-dimensional space to another, should it collapse? The question is if we are capable of transforming between dimensions. I would dare to say we do not even have to. Let me show you why. What is a line if not an infinitely dense consequence of points? What is a plane as well, if not an infinitely dense consequence of lines? The same way we can define three-dimensional space as an infinitely dense consequence of planes. Continuing this idea, a four-dimensional space can be defined as an infinitely dense consequence of three-dimensional spaces, and so on. Let's call it idea number 9. Every n-dimensional space can be defined as an infinitely dense consequence of n-1 dimensional spaces. Then time, or flow of events in general, can be considered as moving from one space to another. For a line, it will be moving from point to point, means for one-dimensional space, time is transitioning between zero-dimensional spaces. For a plane, time will be transitioning between one-dimensional spaces. For three-dimensional space, time will be transitioning between two-dimensional spaces. And for four-dimensional space, transitioning between three-dimensional spaces, and so on. Remember the principle of movie. The first cartoons were created exactly this way, as a fast consequence of slightly changing flat images. And here we can define the difference between space and world. A world is transitioning between spaces of equal dimension, which means the existence of a certain dimensional space in time. Like our four-dimensional world is the existence of three-dimensional space in time. The existence of a four-dimensional space would be a five-dimensional world, and so on. And as there are infinite amount of any dimensional spaces at every point, it leads to an infinite amount of branches of space transitions, of space existence. In other words, an infinite amount of worlds of equal dimensioning. Thus, any dimensional space is static, existing just in a timeless moment, but transitioning from one space to another, or as we consider it moving in time, creates the next level dimensional space, also static, and when it moves in time again, it is the next dimensional space, and that is an endless recursive process. This means we live in a four-dimensional world, simply transitioning from one three-dimensional space to another at each moment of time, and this very transitioning is time itself. This explains why time and space are so closely connected that they curve together, just as Einstein described. And then, if our world is four-dimensional, where changing three-dimensional state every moment of time is changing a three-dimensional space, we can say we move in time from one three-dimensional space to another, and it happens instantly, with each moment of time being a three-dimensional space snapshot. This way, shifting to another four-dimensional world would be not any different than just living, because it would require going through an intersection of these four-dimensional worlds, namely three-dimensional space, which is the moment of time. Even though we do not have to do anything to transit between three-dimensional spaces, as it happens naturally, it still raises an even harder question. How and why does this transitioning between spaces, this flow of time, happen then? Who is selecting which space is next? Who is the editor of life? For me personally, this is another silent proof of God in the core, in the essence of our existence. It also means that every dimensional world has its own time, which is an endless sequence of lower dimensional spaces, meaning time is endless there. Also, any lower dimensional space than ours appears for us as static, while inside it has infinite time. Like if we were able to dive into the moment of our four-dimensional world, meaning into three-dimensional static space, we would experience time as two-dimensional creatures in a moving two-dimensional space. But if we transfer this logic up, it also means that our four-dimensional world, which is moving three-dimensional space, which is a static four-dimensional space, is just a moment of time of a moving four-dimensional space. And a four-dimensional creature living there in five-dimensional world, if it exists, would observe our whole world with its infinite duration of time as just a static space or even object. That whole traveling between dimensions is so abstract that it takes time to absorb. Tools that I have are not enough to illustrate this traveling between dimensions, so I hope for your imagination. Imagine it like if you pause our world and then dive into that frozen snapshot and see it infinitely thin sliced, and you are going through these slices as this is time of that level. But that transition is smooth. You don't feel it, as you don't feel it in our world, because it happens every moment, every infinitely small time point, and then you pause that world again on some slice and dive into that static slice. And again, you see how this slice is composed as cut into infinitely thin lines, and you are going through them one after another, which is time run on that level. And you can pause time there on one of the lines and dive into it and experience time as running from one point of that line to another. Logical question would be, if we dive into the certain point, what is there? What is next then? Food for thought. The question becomes, is it time that drives change, or is it change that creates time? Anyway, this concept of consequence of lower spaces can be a physical representation, physical meaning of time. Let's call it idea number 10. For any n-dimensional world, the flow of time is transitioning from one n-1 dimensional space to another, while any dimensional space is static itself. Thus, in any world, every moment is a transition from one space to another, which echoes the quantum mechanics interpretation of the multiverse. Particles like electrons, described by the wave function, exist in the superposition of all states until measured. Schrödinger's cat that is dead and alive simultaneously. Particles, they are not small balls flying in space around the nucleus. This is the biggest crime physics teaches us at school. But anyway, particles are waves until we measure them and get a certain state. But where do other states go? Do they disappear? Mathematically, wave function cannot collapse, as early quantum explanations tend to say, so-called Copenhagen interpretation by Bohr and Heisenberg, who didn't answer how and why the wave function collapses. Because it didn't. If mathematics says wave function doesn't collapse, then it doesn't collapse. That's it. It means those so-called lost states of particles continue existing somewhere. The question is where? Hugh Everett III in 1957 proposed that there is no collapse of wave function, and when the measurement happens, the wave function evolves into separate non-interacting branches, one for each possible state or outcome. Each branch is as real as ours. Hence, The reality, as a gigantic superposition of all states of all particles, becomes a branching world. And I would dare to say that it doesn't split at the moment of measurement, but it already exists in all the infinite versions, because an infinite amount of spaces of all dimensions exists already in every point of any space. We just choose which one we transit at the moment of measurement. This way, we can give another definition of reality, a superposition of the whole material world. At the moment Hugh Everett suggested his interpretation, he, just a student of Princeton University, was mocked by scientific society. And yet, 60 years later, his multi-world interpretation of quantum mechanics is accepted and as valid as other interpretations. By the way, 2025 is the anniversary year for quantum mechanics, 100 years, a century. I cannot imagine anything as turning the understanding of the world as this. So, happy anniversary to all of humanity. Getting back to the multi-world, this interpretation is absolutely correlating to the mathematical idea of infinitely nested infinities of spaces. Thus, mathematics and physics are not confronting, and no collapses or other violations of mathematical laws, though hard to absorb. But what would be a meaningful life interpretation of a multi-world? That every moment of our life is a crossroad, a choice, a switch that brings us to a certain flow of future events. Also those, what if I did the other way, what if I said that, etc., are existing worlds, the branches we didn't choose. They are not real for our world as we call real what happened or currently exists in our world, but they are as real as our world in a higher sense. Also, it means there are varieties of life roads ahead of each of us depending on the choices we make. It means that we choose the world we live in. We create it with every word, with every step, every decision, thought, and action. That is a power of free will in its grandiose understanding. And then the question will be, is traveling to other universes, to other worlds possible? And the technical answer will be yes, as easy as our transitioning in life at every moment, at every life crossroad. But something is missing. We don't know something for that. I would assume one of the reasons. When we make choices in life, we can anticipate the outcome, at least to some extent. At least it brings us to the similar world we are living in. Our imagination can build at least a preliminary road there. When we measure particles, detecting them, we know what to anticipate. We know possible states of the wave function. With a world we do not know and cannot even imagine, we cannot go there. It looks like our anticipation as a knowledge or as an imagination is a primary ship to the other world. So until we do not know that new world, we cannot anticipate, cannot imagine, and therefore cannot go there, cannot make that choice at the moment we want. Multi-world interpretation can answer the question, why do we not see aliens if they exist? Why don't we know where all those UFOs are coming from and going to if they are real? As we cannot detect any habitable planet nearby or spaceships in the cosmos around us. It could be because these UFOs, if they exist, are coming and going from and to other spaces which we cannot observe. All witnesses say they can disappear momentarily, instantly, like vanish. As any point of 3D space is a connection to other 3D spaces, it could be theoretically explained why they can vanish at any point. So they can be part of another 3D, for example, parallel to ours or our spaces intersect, but we are not capable of going to their space, which is the same dimension as ours. But they can. Remember, that was absolutely an abstract consideration about UFOs. If mathematically infinite dimensional space is possible, can dimensions be negative or not whole numbers? Mathematically, yes. But what does it mean? No one can know that. Only assume. It is completely speculative and will be an abstract consideration, but negatively dimensioned space can just mirror the same space with a positive dimension number. If we postulate that time, as an attribute of the space-time continuum, goes in one direction, showing the direction of events in the causality principle, then space with negative dimensions could just mirror the corresponding space with a positive number of dimensions, and time there will go in the opposite direction in relation to the mirrored space, but which might not be noticeable there. Like matter and antimatter, we just call ours matter and the other anti just because we figured out our matter first. But it could be the other way around if we were made out of antimatter. But what do these dimensional ideas mean for understanding the universe if we apply that understanding to the scientific explanation of the universe's existence and appearance? Some cosmology models like Big Bang model and its extensions like Lambda CDM model say that the universe came out of a singularity, an infinitely small and infinitely dense point where everything was concentrated. Everything concentrated in a point with zero size. But why do we think that it was a point in three-dimensional space? Why did three-dimensional space have to exist already? If so, we should answer the question then, how did this three-dimensional space appear? Science always digs deeper. Other cosmology models say it was an extension of the space itself from the inside, from every point of it. Then again, how did that space initially appear? Alternatively, if we do not make that assumption that three-dimensional space itself existed, we can consider singularity as that starting point of extension, as everything concentrated in zero-dimensional space and no other dimensions existed, just it, meaning no spaces around existed yet, and that further extension was unfolding from the zero-dimensional singularity to one-dimensional space, then two-dimensional, three-dimensional, and so on and so forth, to the infinity of dimensions, as Hilbert mathematical space where quantum mechanics exists. So this world we are living in would not be the whole reality. We are just part of the infinitely nested doll of infinite spaces. That's it. And probably those higher dimensional parts of us as creatures are exactly what yogis call astral, spiritual, etheric bodies, etc., in the limit forming what all religions call soul or higher self. Also, cosmology models of the oscillating universe say that the universe's extension cannot go on forever, and there will be a point where it starts collapsing back, and then extension again, and then collapsing. This way, extension is unfolding from a zero-dimensional to an infinite-dimensional space, and collapsing is the folding of everything into lower and lower dimensional spaces until a zero-dimensional space is reached, which is a singularity point again. And this as well correlates with the Vedic knowledge, where material world creation and the universe's life is a day of Brahma, and then the whole material world is demolished and that is a night of Brahma, and then day, and then night. Brahma, in other words, spirit, is part of Brahman, absolute God. And that unfolding and folding of spaces is kind of a breathing of the absolute God, creation of the material world and demolishing of the material world, unfolding from a zero dimension to the endless dimensions and folding back to a zero dimension, to singularity. Exhale and inhale, out and in, appear and disappear. For me, it all then builds into a construction that is meaningful and self-consistent on all the levels, mathematical, physical, and spiritual. Then my question is, what dimension is absolute God?